Network Functions Virtualization, NFV, and Security Implications. Welcome to this lesson on Network Functions Virtualization, NFV, and Security Implications. NFV is a game changer in modern networking, allowing organizations to replace traditional hardware-based network functions with software running on virtualized infrastructure. This enhances flexibility, scalability, and cost savings. However, virtualizing network functions also introduces new security challenges, including hypervisor vulnerabilities, isolation risks, and misconfigurations. In this lesson, we will explore how NFV works, its security risks, and best practices for securing virtualized network environments. Let's get started. Network Functions Virtualization, or NFV, replaces traditional network appliances like firewalls, routers, and load balancers with virtualized software-based solutions running on commercial off-the-shelf COTS hardware. This allows organizations to deploy, scale, and manage network functions dynamically without relying on dedicated hardware. Think of NFV like moving from physical DVDs to streaming services. Instead of needing separate DVD players for each movie, you can access everything on demand through software. Similarly, NFV eliminates the need for dedicated network appliances, replacing them with flexible, software-based solutions. For example, a telecommunications provider can use NFV to deploy virtualized firewalls and load balancers in different locations instantly, reducing costs and improving service delivery. Here's how to securely deploy NFV in enterprise environments. Use strong authentication and access controls to protect virtualized network functions. Apply encryption to NFV communications to prevent data interception. Regularly update and patch virtualized network functions to fix vulnerabilities. NFV architecture consists of three main components: the virtualized network functions, VNFs, the NFV infrastructure, NFVI, and the NFV management and orchestration, MANO system. First, virtualized network functions, VNFs. These are the software-based versions of traditional network appliances such as firewalls, intrusion detection systems, and routers. Second, NFV infrastructure, NFVI. This includes the hardware and virtualization layer that supports VNFs, such as hypervisors and cloud computing resources. Third, NFV management and orchestration. This component automates the deployment, scaling, and monitoring of VNFs across different environments. For example, a cloud service provider using NFV can dynamically allocate virtualized firewalls to different customers based on their security needs. Here's how to secure each NFV component. Harden VNFs against attacks by applying security updates and patches. Secure hypervisors and virtualization platforms to prevent unauthorized access. Enforce access control policies within the NFV MANO system to prevent configuration tampering. While NFV improves efficiency and scalability, it also introduces new security risks that must be addressed. First, hypervisor vulnerabilities. Since NFV runs on virtualized infrastructure, attackers can target hypervisors to gain control over multiple VNFs, leading to widespread security breaches. Second, VNF compromise. If an attacker exploits a vulnerability in one virtualized network function, they can use it to launch attacks against other VNFs or the underlying NFVI. Third, misconfigurations and orchestration risks. Errors in NFV management systems can lead to unintended network exposure, enabling unauthorized access or denial of service attacks. For example, if a misconfigured NFV firewall is deployed without proper access controls, attackers could exploit it to bypass security defenses and access internal systems. Here's how to mitigate NFV security risks. Use secure hypervisors and regularly update them to patch vulnerabilities. Apply strict isolation policies to prevent compromised VNFs from impacting other network functions. Implement automated security testing to detect misconfigurations in NFV environments. NFV is widely used in cloud and edge computing environments, enabling dynamic scaling of network functions. However, securing these deployments requires additional considerations. In cloud-based NFV, organizations must ensure secure multi-tenancy, preventing one customer's VNFs from interfering with another's resources. Cloud providers must enforce strict identity management and data isolation policies. In edge-based NFV, where VNFs are deployed closer to users for lower latency, physical security and network segmentation are crucial. Edge locations often have limited security controls, making them attractive targets for cybercriminals. For example, a telecommunications provider deploying NFV at edge locations must ensure that all virtualized routers and firewalls are properly secured to prevent unauthorized access from public networks. Here's how to enhance NFV security in cloud and edge environments. Use strong tenant isolation in cloud-based NFV to prevent cross-customer attacks. Encrypt all NFV traffic to protect data moving between cloud and edge locations. Deploy security monitoring tools to detect and respond to potential NFV-based threats. Let's look at a real-world example of how NFV security is applied in a telecommunications network. A global telecom provider deployed NFV to replace traditional hardware-based firewalls and load balancers with virtualized network functions. However, early security assessments revealed weaknesses in hypervisor protection and configuration management. To address these risks, the provider implemented strict access controls for NFV administrators, used encrypted communications between VNFs, and deployed automated security scanning tools to detect misconfigurations. As a result, the telecom provider improved network security while maintaining the scalability and flexibility of its NFV-based infrastructure. Here's how to apply similar security measures to NFV deployments. Use role-based access control RBAC for NFV management systems. Monitor VNF activity for signs of compromise or unauthorized modifications. Conduct regular security audits to identify and address NFV vulnerabilities. Now let's summarize what we've learned about Network Functions Virtualization, NFV, and its security implications. NFV replaces hardware-based network functions with virtualized software, improving flexibility and scalability. Key NFV components include VNFs, NFV infrastructure, NFVI, and NFV management and orchestration mano. Security risks include hypervisor vulnerabilities, VNF compromise, and orchestration misconfigurations. Securing NFV requires strong access controls, encrypted communications, and regular security audits. Organizations must implement cloud and edge security measures to protect NFV deployments. By following these best practices, businesses can take advantage of NFV's benefits while ensuring a secure and resilient network infrastructure. This concludes our module on Network Functions Virtualization, NFV, and security implications.